Hello, my name is Lindsay Baker, and I'm a scientist at the Gatorade Sports Science Institute. In this session, I am going to discuss the topic of hydration assessment and recommendations. Throughout this presentation, I'll cover fundamental concepts of body water and electrolyte balance, including hydration terminology and basic physiology. I'll also discuss how to assess hydration status, sweating rate, and sweat sodium losses, and provide some example calculations. Finally, I'll provide an overview of practical hydration recommendations for athletes. Total body water accounts for a large percentage of total body mass. The percentage varies among individuals, but is about 50 to 70% of body mass. The reason it varies is because of differences in body composition, as lean tissue contains a lot more water than adipose tissue. And actually, if you know the amount of fat-free mass in your body, for example, through body composition testing, you can calculate total body water because we know that total body water is a constant fraction, about 73% of fat-free mass. Next, let's talk a bit about hydration terminology. Euhydration is the term used for normal baseline body water content. Notice that this is represented by a sinusoidal wave, as small fluctuations, fluid loss, and fluid intake are expected throughout the day. The amount of fluctuation that can occur is up to about plus or minus 2% of total body water. The process of losing body water is called dehydration, and then when in a steady state, body water deficit, that is called hypohydration. And then rehydration is the process of drinking fluid to replace losses to get back to euhydration. On the other hand, if someone overdrinks to the point where they've increased body water by more than about 2%, then they are now in a hyperhydrated or overhydrated state, at least until diuresis kicks in and they get back to euhydration after urinating the excess water. This slide provides a list of the hydration-related terms just discussed. It may be helpful to refer back to this slide as needed to make sure you understand the difference between euhydration, dehydration, rehydration, hypohydration, and over or hyperhydration. So next, let's talk about some basic physiological changes that occur in the body in response to dehydration. Total body water is distributed between two main compartments: intracellular water, which is where most of our water is found, and extracellular water, which is further divided into interstitial space, or the water between cells, and the water in our blood, or plasma. The intracellular compartment accounts for approximately 55 to 65% of total body water, while the extracellular compartment accounts for the remaining 35 to 45%. The extracellular space can be further divided interstitial fluid, intravascular fluid, or plasma. So what are the effects of hypohydration on human physiology during exercise? When a body water deficit occurs, we see a decrease in plasma volume. This is called hypovolemia. Because sweat is less salty than blood, the blood plasma becomes more concentrated as we lose sweat during exercise. This is called hyperosmolality. These changes result in cardiovascular strain, including a decrease in stroke volume and higher heart rate to try to maintain the same cardiac output. A greater rise in body core temperature also occurs because of impaired sweating and skin blood flow responses, and an early onset of fatigue leading to reduced performance. Specifically, hypohydration that exceeds 2 to 3% of body mass loss can impair cognitive performance, such as attention or motor coordination. It can impair performance during team or skill-based sports, as well as aerobic exercise and muscle endurance, strength, and anaerobic power, especially if the exercise takes place in hot and humid conditions. For more details on this research, please see Sports Science Exchange article numbers 128, 152, and 165 on gssiweb.org. Now, to finish this section on physiology of fluid balance, let's talk about the effects of overhydration on human physiology during exercise. The concern in this situation is the development of hyponatremia. Hyponatremia is primarily due to overdrinking hypotonic beverages, such as water or other low-sodium fluids, at a rate that exceeds the renal system's capacity to excrete the excess fluid. Other contributing risk factors include long exercise durations, slow pace, and body size. Another important factor is, of course, the other part of the equation, and that is large sodium loss in athletes who are heavy or salty sweaters. Okay, so why is this a problem? Basically, it's because sodium balance plays a key role in water movement between fluid spaces. When the extracellular fluid sodium decreases, it creates an osmotic gradient, thereby resulting in fluid movement into cells to restore osmotic balance. The consequence is cell swelling, and in very severe cases can cause edema in the brain and lungs, and even death. Body mass gain is less common than hypohydration during exercise, but potentially more dangerous. So this is why overzealous drinking should be avoided. So now we are going to switch gears and talk about hydration assessment. First, let's talk about pre-exercise hydration assessment. The recommendation is to consider multiple markers, including body mass, urine concentration, and thirst. As this Venn diagram shows, hypohydration is likely if two methods indicate hypohydration, and very likely if all three methods are above cutoffs. You can have more confidence in your assessment if you consider multiple markers versus if you use any one in isolation. And for best accuracy, it is suggested to assess this first thing in the morning. For more information on this topic, please see Sports Science Exchange article number 92 on gssiweb.org. Let's dive a little deeper into the practical markers of urine concentration. Urine color is often assessed using a scale from 1, very pale, to 8, very dark. A urine color of 5 or higher may be indicative of hypohydration, while a urine color in the range of 3 or 4 suggests the athlete is probably hydrated. Urine color charts can be posted in bathrooms to provide reminders to athletes to check the color of their urine as a practical tool to estimate hydration status. Another measure of urine concentration is urine-specific gravity, or USG. A USG greater than about 1.020 to 1.025 may indicate that the athlete is hypohydrated. But again, it is best to use multiple measures, such as body weight and thirst, in addition to urine concentration to assess pre-exercise hydration status. Okay, let's move to hydration status assessment after exercise. How do you know whether an athlete is euhydrated, hypohydrated, or overhydrated? Actually, the most accurate and practical measure of acute changes in hydration status is by measuring percent change in body mass from before to after exercise. This is because almost all body mass loss that occurs during a typical, say, 1 to 2 hour training session or game is from sweating. For example, 2% hypohydration means that there is a 2% body mass deficit through fluid loss. It is important to note that this method works best for exercise durations less than about 3 or 4 hours. For longer periods of physical activity, such as endurance events, other non-sweat sources of body mass loss, such as fuel oxidation, can lead to significant overestimations and body water loss. Okay, let's go through some specific examples. First, to measure an athlete's change in hydration status, you'll need a digital platform scale with a precision of 0.1 kilograms or better, and you'll need a towel or two. Before exercise, ask the athlete to use the restroom and void his or her bladder and bowels. Then weigh the athlete while he or she is wearing minimal clothing. A best practice is to weigh the athlete twice to make sure the values are consistent. Then after exercise, ask the athlete to towel dry and then weigh the athlete while wearing the same minimal clothing as they wore before exercise. For more information on this topic, please see Sports Science Exchange article number 161 on gssiweb.org. In this example, we have a football player who weighed 104.55 kilograms before practice and 101 kilograms after practice. Calculate the athlete's percent change in hydration status after practice. We know body mass decreased from 104.55 kilograms to 101 kilograms. So the change in, or delta, body mass is equal to minus 3.55 kilograms. So we plug the values into the equation and hydration status equals negative 3.4% change in body mass, or 3.4% hypohydration. In this example, we have a tennis player who weighed 56.35 kilograms before the match and 55.45 kilograms after the match. Calculate the athlete's percent change in hydration status after the match. We know that body mass decreased from 56.35 to 55.45 kilograms. So the change in body mass is equal to minus 0.90 kilograms. So we plug the values into the equation, and hydration status equals negative 1.6% change in body mass, or 1.6% hypohydration. In this example, we have a trail runner who weighed 66.15 kilograms before exercise and 66.80 kilograms after her training run. Calculate the athlete's percent change in hydration status after exercise. In this case, body mass increased from 66.15 to 67 kilograms. So the change in, or delta body mass, is equal to plus 0.65 kilograms. So we plug the appropriate values into the equation, and hydration status equals plus 1.0% change in body mass, or 1% overhydration. In this next section, I'll provide an overview of sweating rate, how much it can vary among athletes, why it varies, and how to measure it. So you have probably noticed when playing sports or even watching games in person or on TV that some athletes sweat so much that they are dripping sweat all over the place, while other athletes may hardly sweat at all. There is, in fact, large variation in sweating rates among athletes. GSSI have conducted a retrospective analysis of the athletes we've tested, and as you can see in this histogram, the sweating rates of these 1,300 athletes of various sports tested in a wide range of conditions is anywhere from about half of a liter per hour up to 2.5 or even 3.0 liters per hour in rare cases. Why is there so much variability in sweat rates? Well, there are several factors involved, and some of the most important factors are exercise intensity and body size. Basically, the faster you run or the more weight you are carrying, the more metabolic heat that is produced by the working muscles. The environmental conditions are also very important in determining how much sweat needs to be produced and evaporated in order to adequately cool the body during exercise. Then there is a list of several other factors shown here that can also modify sweat loss, but generally play a smaller role than intensity, size, and environment. So because of this variation, it is important to measure individual sweat losses. This can be done by measuring the pre to post exercise change in body mass and correcting for all of the non-sweat sources of body mass change. That is, any food or fluid consumed during exercise and urine loss. It is also important to note here that for the most accurate measure of sweat loss, for example, maybe for research purposes, you'll also need to correct for respiratory losses to account for fuel oxidation and water vapor loss. These losses can be estimated if you know energy expenditure. However, because of the relatively small contribution of respiratory losses to total body mass loss, and because energy expenditure is difficult to measure, this part of the equation is usually dropped for acute bouts of exercise up to about 3 hours, especially for measurements done in the field. To measure sweat loss, you'll need a digital platform scale, towels, a clock, drink bottles, small digital scale for weighing food and fluid, a urine cup, and a scale for weighing the urine. Instructions are similar to measuring hydration status, but this time, in addition to pre- and post-exercise body weights, you'll need to weigh the drink bottles and food that the athlete plans to consume. In addition, if the athlete needs to use the restroom after they've weighed in or at any point during exercise, you'll need to ask them to collect the urine in a cup and weigh it. More information on best practices for measuring sweat loss can be found in Sports Science Exchange article number 161 on gssiweb.org.